So, ladies and gentlemen, given two functions f and g, remember, you can perform various function operations. You can add two functions together. So I can take my f of x and add it to g of x. You can add two functions together. The domain, when you add them together, is going to be the values of whatever your final answer is, as well as the domain of each individual function. You also can subtract two functions. So you can take f of x and you can subtract g of x from it. And again, the domain, just like adding, you have to look at the domain of f of x, you have to look at the domain of g of x, look at the domain of your final answer, and put all those pieces together to come up with the domain of f of x minus g of x. You can also multiply two functions together. So f of x times g of x. Again, the domain is going to consist of whatever that product is of f and g, along with the domain of function f and function g. You can divide two functions. So we can take f of x and divide it by g of x. And again, you have to be careful because remember, you cannot have 0 in the denominator of a fraction. So the domain is going to be all real numbers except wherever you end up with 0 in the denominator of your final answer. So like I said, you can add, subtract, multiply, and divide functions. So for example, given two functions here, we have f of x and we have g of x. So let's go ahead and let's add f of x plus g of x together. So there's a lot of different ways you may see function notation. Remember, this is just equal to f of x plus g of x. So f of x is defined by this rational function x minus 3 over 2x plus 5. Plus g of x is defined by 3x plus 5 over 2x plus 5. So I can go ahead and I can add. Luckily, the denominators are already the same, so I don't have to worry about finding a common denominator. So I'm going to have 2x plus 5 on the bottom. And remember, I'm going to add the numerators together. So x plus 3x is 4x. Negative 3 plus 5 is 2. And again, you want to make sure you're checking your answers to make sure that they are in simplest form. You can factor a 2 out of the numerator. That'll give me a 2x plus 1 over 2x plus 5. But as you can see, there is no common factor to cancel out, so I know my answer is in simplest form. So any questions on how you can add two functions together? Yes?
So can we put it either way?
Either way, yeah. Now, the only thing is, though, if you don't factor it and it can be simplified, you want to make sure you always simplify it. So now the big question is the domain. Because the question is a two-part question. They want you to find the following and then state the domain. So look at your final answer. The domain is going to be what? All real numbers except where the denominator is equal to 0. So where is your denominator equal to 0? At what particular x value? What's the x value going to be? So negative 5 over 2. Because remember, you have to take the denominator and set it equal to 0. So the domain is going to be all real numbers except x cannot be equal to negative 5/2. You also, remember, you want to look at your final answer. You also need to look at your two original fractions. So again, the domain for f of x is also all real numbers except negative 5/2. The domain for g of x is all real numbers except negative 5/2. So the domain is just going to be this one. Had, for example, you had two fractions with different denominators, let's say this was an x plus 4, you would need to say all real numbers and include that negative 4 as well. Because if it's not in the domain in the original one, it's not going to be in the domain of the final answer because it wasn't there to begin with. So you want to make sure you look in all three places. So like I said, you can also subtract. So we have f of x minus g of x. So again, this is another notation for functions. It's asking you to subtract these two functions. So we have x minus 3 over 2x plus 5 minus 3x plus 5 over 2x plus 5. Luckily, just like with adding, the denominators are the same. Now, what you have to be careful of, guys, is you have to be careful with this negative sign. Remember, guys, you need to distribute the negative sign all the way across the numerator of that second fraction when you go to combine your like terms. So x minus 3x is a negative 2x. Negative 3 minus 5 is a minus 8. And again, make sure that your answer is in simplest form. I can factor out a negative 2, and that's going to give me an x plus 4 over 2x plus 5. So again, your fraction can't be simplified. So either answer would be acceptable. All right, so any questions on subtracting two functions? So again, what's the domain going to be? Just like when you add it, it's going to be all real numbers except negative 5/2. Again, look at the denominator. When you have a fraction, you have to look to see what would give you a 0 in the bottom and exclude it from the domain. So the domain is going to be all real numbers except negative 5/2. So any questions on that one? So next operation, remember, is you can multiply. You can multiply two fractions together. So again, this is telling you to take f of x and multiplying it by g of x. So I'm going to take x minus 3 over 2x plus 5, multiply it by 3x plus 5 over 2x plus 5. How do you multiply fractions together? What do? You simply do what? You're going to multiply what? Straight across. So you are, remember, going to have to FOIL the numerators together. So you do have to multiply out the numerator. The denominator, 2x plus 5 times itself, is just going to be 2x plus 5 to the second. Again, before you multiply it out, you can double check to see whether or not you can cancel any common factors. There are no common factors to cancel, and actually, you don't have to multiply out. Just go ahead and leave it alone. That's fine. Okay? So any questions on how you can multiply those together? What's the domain going to be? The domain's going to be what? Same thing. All real numbers such that x cannot be equal to negative 5/2. Okay? So any questions on how you can multiply those fractions together? Again, you can also divide. You can take your f of x and you can divide it by g of x. Now remember, with division, there's two ways you can write division. You can write it as a fraction vertically, or remember, this is equivalent to taking f of x and dividing it by g of x. So with the rational expressions, it may be easier to look at the division problem written out horizontally versus vertically. All right, so again, I know that f of x is my x minus 3 over 2x plus 5. I'm going to divide by g of x, which is 3x plus 5 over 2x plus 5. How do you divide fractions? Which one do I flip? The last one, the one that comes after your division sign. So I'm going to multiply by the reciprocal. Now, what do you notice you can cancel out? You can cancel out this common factor of 2x plus 5. So I'm left with my final answer of x minus 3 over 3x plus 5. So now let's talk about the domain. You have to look in three places. You've got to look at your final answer. What's the domain of my final answer after I got done dividing? The domain is going to be all real numbers except what? Negative 5/3. However, you also have to look at your two original functions that you divided. What was the domain of f of x and g of x? All real numbers except what? Negative 5/2. If negative 5/2 isn't a number in this domain to begin with, it can't be in the domain of your final answer because negative 5/2 wasn't there to begin with. So not only do you have to include the negative 5/3, you also have to include the negative 5/2. So that's your domain. Okay? Because negative 5/2 wasn't there to begin with. Okay? So any questions on those four? So adding, subtracting, multiplying, or dividing. All right, another thing you guys did last year was composition. So remember that open circle, that fog notation? means you're doing composition of functions. So this f open circle g is actually your f of g of x. So some of you may recognize the parenthesis notation with the open circle. Remember that open circle is not multiplication. So very similar when we talk about the domain of a composition of functions. You not only have to look at the final answer, but you have to look at the domain of your input function. So again, you have to look at the domain of g of x as well. Because again, you're taking g of x and plugging it into f. So if there's a number not in the domain of g of x, it can't be in the domain of your final answer because that value wasn't there to begin with. So here's some examples. I'm giving you two functions, f of x and g of x. What is g of 4 asking you to do? What does that 4 represent? An x value. So what am I going to do with this x value? I'm going to take 4, and what am I going to do with it? I'm going to plug it into what? G. So g of 4 is equal to 4 times 4, which is just 16. Remember, inside the parentheses is your x value. That's your input. You're plugging it into a function. You guys go ahead and try b for me. Do we all get -1 for f of -1? Okay. So again, evaluating functions. So now, f, open circle, f of 2. Remember, that's composition. So I'm taking f, and I do a composition with f of 2. So remember, when you do composition, you always want to work on the inside, the most inner part first, and then work your way out. So cover up what's on the outside and look on the inside. The first thing you have to do is you have to find f of 2. So to find f of 2, just like I did in the previous two examples, I'm going to take 2 and plug it into function f. So 2 times 2 squared minus 3. So that's 2 squared is 4, 4 times 2 is 8, 8 minus 3 is 5. So any questions on how I found f of 2? So now what I'm going to do is replace. Take out my f of 2 and replace it with a 5. So now what I want to do is I want to find f of 5. So like I said, you work on the inside and work your way out. Find f of 2, replace f of 2 with 5. Now look on the outside and you want to find f of 5. So I'm going to plug 5 back into function f. So 2 times 5 squared minus 3. So 5 squared is 25. Watch your order of operations. 25 times 2 is 50. 50 minus 3 is 47. Okay? So any questions on doing composition with numbers? So here's my f of g of -2. Again, I always rewrite it using my parenthesis notation when I see that open circle. What's the first thing you're going to do here? You're going to have to find what? You're going to find what? G of -2. So I'm going to take -2 and plug it into function g. So g of -2 is equal to 4 times -2, which is -8. So then I'm going to rewrite g of -2 as -8. So now I want to find f of -8. So I take -8 and I plug it into function f. So 2 times -8 squared minus 3. So 64 times 2 is 128. 128 minus 3 is 125. So any questions on D? You guys go ahead and try E for me. Did you guys all come up with 20? All right, so again, you have to find your f of -2 first. So we should have given you 5. Then you need to find g of 5, which is 20. So when you do composition, you can do composition with numbers. Taking a number, plugging it into a function, then plugging that value into another function. You also can do composition with functions. You can take functions and plug them into other functions. So g of f of x, remember, means we're going to take g of f of x. So this is where you're not going to get a number as an answer, you're going to get a whole new function. Again, still work on the inside. So f of x, remember, is defined as 2x squared minus 3. So I'm going to replace f of x with what it's defined as, 2x squared minus 3. Now I'm going to look on the outside. Remember, what's inside the parentheses is your input. You're inputting 2x squared minus 3 into function g. So anywhere I see an x and g, I'm going to replace it. So 4 times, take out my x, replace it with the input, which is 2x squared minus 3. So what used to be 4x, I take my x out and I replace it with what is defined as that function f, which is the 2x squared minus 3. And then I can distribute. So 8x squared minus 12. And again, you guys should have done that last year in Algebra 2. Yes? Cleaning out some cobwebs, kind of remember this a little bit? Remember, composition of functions is not commutative. F of g of x may not necessarily be equal to g f of x. So when I do my composition f of g of x, it's not necessarily going to be the same answer as when I did g f of x. Always start on the inside and work your way out. What is g of x equal to? G of x is equal to 4x. So I'm going to rewrite g of x as 4x. Now look on the outside. So now what I'm going to do in function f, anywhere I see an x, I'm going to take it out and replace it with a 4x. So 2 times something squared minus 3. So I take out my x and I'm going to replace it with the 4x. Follow your order of operations. You always have to do your PEMDAS. Evaluate your exponent first before you multiply. You're not going to take 8x and square it. It's going to be 2 times 16x squared minus 3. Don't forget, you're squaring not only the x, but the coefficient in front of x, which is the 4. So I end up with 32x squared minus 3, which then you can clearly see that f and g are different. Okay. So any questions on g? So when you take a look at h, this is telling you I'm doing a composition. I'm taking g, I'm going to do a composition with f of x plus 4. So before you can do anything, start on the inside. I have to find f of x plus 4. So what am I going to do with this x plus 4? I'm going to have to plug it into what function? I'm going to plug it into what? F. So again, it's going to be 2 times x plus 4 squared minus 3. Now I'm going to look on the outside, and now what I have to do is take this whole entire expression and plug it into g. Now this is kind of an eeny, meeny, miny, mo. You are going to have to simplify this all the way. You can substitute it into g first and then simplify, or simplify before you plug it in. I'm going to go ahead and simplify this before I plug it in. By order of operations, what am I going to do first? Am I going to distribute the 2? Am I going to FOIL x plus 4? What operation do I have to do first? I have to do the exponent, so I have to FOIL first. Remember, x plus 4 times x plus 4. It is not x squared plus 16. You have to write this out as x squared, because remember you're doing x plus 4 times x plus 4. So my first terms are x squared. Outer term is 4x, inner term is 4x, so I'm going to get an 8x. And then 4 times 4 is 16, minus 3. I have 2 operations left to do. By PEMDAS, what's my next operation to do? I'm going to have to distribute the 2. So I have 2x squared plus 16x plus 32 minus 3. So finally, what I have here is 2x squared plus 16x. 32 minus 3 is 29. So any questions on how I simplified that or multiplied it out? Now I can take this 2x squared plus 16x plus 29, plug it into function g. So anywhere I see an x, I'm going to take it out and replace it with that. So I'm going to end up with 4 times 2x squared plus 16x plus 29. So that gives me 8x squared plus 64x plus 4 times 29 is going to give me 126, I believe. Is that right? Yeah. Yes, George.
So if I just left it with the 4 on the outside and didn't distribute it, would it be?
No, it wouldn't be. As long as you left in that form. Either one would be acceptable. Yes, Emily. 116? I can't multiply today. Sorry about that. Thank you. Okay? You guys go ahead and try and do I for me right now. Go ahead and do I. And then we'll take a look at tables. So like I said, any questions on doing function operations when you're given equations? So like I mentioned, not only do you have to be comfortable doing these operations involving equations, you also have to read tables. So for example, here's a table. Remember, inputs and outputs. Inputs are your x. Outputs is what happens when you plug them into some function. So I've got 2 y values. I've got a y value for function f. I've got a y value for function g. And of course I have my x's, which are my inputs. So f of 1. Remember, 1 is your input. That's your x value. So when x is equal to 1, I want to find the output for function f. So what is the output for function f from the table? 8. So you also can do composition from a table. F of g of 3. So from the table, again, just like what you did, you want to start on the inside and work your way out. You want to find g of 3. 3 is your input. So what's the output going to be when x is 3 for function g? The output's going to be what? 4. So g of 3 is 4. Now look on the outside. Now I want to find f of 4. So 4 is my x value. So when x is equal to 4, what is the output for function f? That's going to be a value of what? 2. G of f of 3. Again, start on the inside. What is f of 3 from the table? F of 3 is equal to what? 5. Now look on the outside. What is g of 5? G of 5 is what? 7. So any questions on how you read the table? You guys go ahead and do the next 3 for me. Any questions, guys, on reading and doing composition from a table? Again, you can also add, subtract, multiply, divide, etc. But any questions on how you can read the tables? All right, next one is you also, like I mentioned, have to be able to do operations involving a graph. Remember, graphs are made up of an infinite number of points. Points have to have an x value. Points have to have a y value. So when you're trying to read the graph, you have to find the x value on that particular graph and find the y coordinate at the individual point. So for example, let's take a look at A. I've got 2 lines. Sometimes it's easier if you highlight one. Line F I'm highlighting in yellow. So there's my f of x. G of x is my second line. So again, I want to find f minus g of 1. So what this notation means is you want to find f of 1 and subtract from that g of 1. So remember, line F is the one I highlighted in yellow. So what I need to do on line F is I want to find where the x value is 1. So go to 1 on your x-axis. And take your pencil, slide it up and down until you hit line F, and find that point on the line where x is 1. Well, what's the y coordinate on line F when x is 1? What's the y coordinate of that point? The y coordinate is what? 0. So then what is f of 1 going to be equal to? F of 1 is going to be equal to 0. Minus. Now I want to do the same thing on line G. Again, find where x is equal to 1 on the x-axis. Slide your pencil down until you hit line G. So on line G, when x is 1, what's the y-coordinate of that particular point? The y-coordinate is what? -3. So then what is g of 1 going to be equal to? G of 1 will be equal to what? -3. So then 0 minus -3 is just going to give me a 3. So that's how you do function operations from graphs. All right, any questions on that one? Let's take a look at B. G divided by f of 3. This is a notation that they want you to find g of 3 and divide it by f of 3. Again, there's a lot of different ways they can write in function notation the actual operations. So again, the x value is 3, so I want to go to 3 on my x-axis, so 1, 2, 3. Go to line G, and I want to find the point on line G where x is equal to 3. So when x is equal to 3 on line G, what is the y value? The y value is what? 1. So what is g of 3 going to be equal to? G of 3 is going to be equal to 1 over. Now I need to find f of 3. So again, go to 3 on your x-axis. Take your pencil down. Again, in this case, I highlighted my line F in yellow. Find the point on line F where you have an x value of 3. So when x is equal to 3 on line F, what is the y value? The y value is negative 2. So what is f of 3 equal to? F of 3 is equal to what? -2. So your answer is going to be -1/2. What operation are they asking you to do in C? Is this a composition or is this a multiplication? Multiplication. How do you know it's not composition? Closed circle. So remember, you have to find f of 4 and multiply it by g of 4. So you go ahead now and see if you can find f of 4 and find g of 4 and multiply those two values together for me. Did you guys come up with -9? Yep, good. Good. I read the graph right. Shoo. So you can also do composition from the table. Again, we want to find g of f of -3. Again, you still always start on the inside first. So I want to find f of -3. So again, go to -3 on the x-axis. And what I'm going to do is I'm going to take my pencil. Again, line F is my yellow one. I'm going to slide it up until I hit the point on the yellow line where the x value is -3. So when x is -3, the y value is what on line F? The y value is what? 4. So I know f of -3 is 4. Now I want to look on the outside, and I want to find g of 4. So again, I'm going to go to my x-axis, go to 4 on my x-axis. And again, I'm going to use my line g of x, the one that I didn't highlight. And the point on line G where x is equal to 4, what's the y coordinate going to be? That's going to be a y coordinate of what? 3. So your answer is 3. Okay? You guys go ahead and do the next two on your own. So any questions, guys, on how you can do composition or function operations one of the three ways? Either given equations, finding them algebraically, given a table, being able to do them from a table, or doing them from a graph. So those are the three representations you have to be comfortable with doing the function operations. So any questions on the tables, the graphs, or the equations? Last thing, because I know you guys love complex fractions oh so much. So we work with rational functions a lot. You've got to be very comfortable with these fractions. So here I'm giving you some examples of doing composition, and then again they want you to state the domain. So I need to find f of g of x. Again, that open circle notation means you're doing that f of g of x. Remember, it's just substitution, inputs and outputs. So I need to start by taking g of x, and which is defined as 4 over x minus 1. So I'm going to replace g of x with 4 over x minus 1. That's my input. I need to take 4 over x minus 1, plug it into function f anywhere I see an x. So again, in function f, I still have a 1 in the numerator. Over, I'm taking my x out of function f. I'm replacing it with this 4 over x minus 1 plus 2. Remember, this was the x I took out, and I replace it with the input. We know better, hopefully by now, than to leave complex fractions. What are we going to multiply everything by to simplify the complex fraction? Multiply everything by a what? X minus 1. Remember, everything gets multiplied by an x minus 1. So my numerator then is going to be 1 times x minus 1, which is x minus 1. Remember, when I take 4 over x minus 1 and multiply it by x minus 1, I can cross out the x minus 1, and that leaves me with a 4. Plus, I have to distribute the 2. That's going to give me a 2x minus 2. So now when I simplify, it's going to be x minus 1 over 2x plus 2. So any questions on how I simplified that complex fraction? Now again, you can factor the denominator to see if you can simplify it, which you find that you can't. So that's your final answer. So any questions on how I did a composition with those rational functions? Now let's talk about the domain. There's two things you have to look at when you're talking about the domain when you're doing composition. Obviously, you have to look at your final answer. So you have to look at the domain of your final answer. You also have to look at the domain of that input function. So there's two places you have to look, and you have to put those values together. So let's look at my final answer. What's the domain of the final answer? It's going to be all real numbers except what? -1, because that's where I'll get a 0 in the denominator. So I know it's going to be all real numbers such that x cannot be equal to -1. Now look at the domain of your input function. What's the domain of 4 over x minus 1? What x value would give you a 0 in the denominator? That would give you what's the x value going to be? 1. So the domain is going to be all real numbers except for -1 and 1. So you've got to look in those two places when you're talking about domain of composition of functions. Your final answer, because 1 is not in this domain to begin with. 1's not here. So remember what you're doing. You're taking this function, including all of its x values, you're plugging it in somewhere else. Well, if 1's not here to begin with, which we know it's not, it certainly can't be in the domain of the final answer. Okay? Because 1 wasn't there to begin with, so you've got to look in both places. So as you know, composition is not commutative. Let's take a look at g of f of x. So I have g of f of x. So again, now I'm going to take my f of x, which is 1 over x plus 2, and I'm going to plug it into function g. So again, in function g, I have a 4 in the numerator over. I have to take the x out and replace it with 1 over x plus 2 minus 1. Remember, this is where that x originally was in function g. How do you simplify that? What are you going to multiply everything by? We have to multiply everything by a what? X plus 2. So everything gets multiplied by an x plus 2. So I have to distribute the 4, so that's going to give me a 4x plus 8 in the numerator, over 1 over x plus 2 times x plus 2, the x plus 2's cancel. So that's going to leave me with a 1. Be careful, you have to distribute the negative sign all the way through. That's going to be a minus x minus 2 in the denominator. So I have 4x plus 8 over 1 minus 2 is a -1 minus x. So there's your composite function. And I know I could factor a 4 out of the numerator and write 4 parentheses x plus 2. I still can't do any simplifying. So any questions on how I did that composition? So now let's talk about the domain. Remember, there's two places you have to look. You have to look at your final answer. You have to look at your original input function. So what value for x? Let's take a look at your final answer. What value for x would give you a 0 in the denominator? X cannot be equal to what? -1. So I know it's going to be all real numbers except -1. Look at your original input function. What value for x would give you a 0 in the denominator of the input function? It's going to have to also include what? -2. So there's your domain. Okay? So any questions on B? Look at C, f of f. Remember, this is you're doing f of x. So you can do a composition of a function with itself. Always work your inside out. So I'm going to take f of x, which is 1 over x plus 2. And I'm going to plug it back into function f. So you guys see if you can finish that for me. See if you can do the substitution and then simplify the complex fraction and tell me what the domain is going to be. So hopefully once we simplified the complex fraction, we came up with x plus 2 over 2x plus 5. Any questions on how I simplified that complex fraction? And then again, to find the domain, it's going to be all real numbers except you've got to look at the domain of your final answer and then your original input, the -2 and -5/2. So any questions on the domain or the composition there? Right? You guys go ahead and do D for me, and then we're done. So again, we're doing the composition of G. You're doing a composition with G of x. So we're going to take G of x, which is the 4 over x minus 1, and we're going to plug it into itself. To see if you can find that composition and find the domain. So you're done, you can look up here. All right, you should end up with, after the composition is done, the 4x minus 4 over 5 minus x once you simplify the complex fraction. And again, the domain is going to be all real numbers except for 5, which is the domain of your final answer, and then 1, which is the domain of that input function. All right, so any questions, guys, on doing the composition of functions and finding the domain when you do composition? Again, when you're doing composition, guys, and I ask you about domain, if the domain of your input function is all real numbers, and this domain is all real numbers, then you know the domain is all real numbers. If the domain of your input function is all real numbers, and then the answer is like all real numbers except 1, then the domain is going to be all real numbers except 1. You got to put all those pieces together. All right, so any questions on 7.4? Like I said, 7.4 is not on your quiz on Wet Friday. Quiz Friday is just on the 7.1 through 7.3. Piecewise functions, your transformations, and then solving using all those different techniques, including completing the square. All right? So your homework tonight, guys, you have 2 things for me.